substitution reaction, which is very easy. You have studied in all this chapter that an electrophile will attack. So first we are going to deal with the bromination, and basically in bromination we add boron. Bromination we add boron. So it's a very simple reaction. If you are going to react aniline with bromine water, this is your benzene, and if you are going to attach NH2, it will be aniline. So if you are going to react this with bromine water, I just took 3 moles of bromine molecule, and it is bromine in the presence of water. Then 3 bromine will be attached with this. And 3 HBr will be as a byproduct. So its name is 2,4,6 tribromoaniline. So if you want to have only one bromine attached to this aniline, we will do it in a different way. We will use another reagent. So this is your bromination. Please do write it.
Done.
Very good. What I told you, if you want to attach only one bromine, we are going to use acid anhydride in the presence of pyridine. So if you are going to react this amine with acid anhydride, which means CH3CO whole twice O, and here it is in the presence of pyridine. You know, when amine reacts with acid anhydride, then amide forms. So here amide will form. One of the hydrogen will be replaced by this part, that means C double bond O, CH3. And if you are going to react this with Br2 in the presence of carboxylic acid, then Br will be attached at para position, and the rest part will be as it is NHCOCH3. And if you are going to react this with acid or base, OH minus or H plus, then you will be getting again the aniline like this. And its name is 4-bromo-aniline. There will be another product like ortho, para, ortho will be also there, but this will be the major. So we will proceed with this. And this has a name, which is N-phenyl ethanamide, which has a common name, acetanilide. Please do write. Let me know when you are done. Are you done with this?
Yes.
Okay. After bromination, we have nitration. After bromination, we have nitration. And we are going to add nitro group to this aniline again. So how we are going to add for nitration, we use nitric acid, that is HNO3 in the presence of H2SO4. And then the reaction should be carried in cold. The temperature should be very low, 288 Kelvin. Then you will be getting three products. The first one will be addition of this nitro group at para, which is 51%. That means it is major product. And then we have another product, that is NO2 will be attached at this position, meta, which is 47%, and the lowest or the minor product will be ortho. This is your NO2 and this is your NH2, and it will be only 2%. What if we want to have only this as a very major product? We will again use that acetic anhydride. Acetic anhydride. So you can see we are going to use this again. And if acetic anhydride is going to react with aniline, it will again form amide. It will again form amide NHCOCH3. And after this, you are going to react this with HNO3 in the presence of H2SO4. The temperature should be the same. Then there will be addition of NO2 at para position. And here it is amide. To remove this amide and convert it into amine, we again will use OH minus and H plus acid or base. This will be converted into this. And the name of the compound, it will be para nitroaniline or 4-nitroaniline. So this is how we do nitration. Then we will deal with sulfonation.
कभी बोरिंग एप्लीकेशन
Let me know when you are done with this.
Glancer.
Now we are going to start this sulfonation. So here is your sulfonation. That's very easy. Sulfonation, that means you are going to add sulfonic group. So see, here is your NH2, which is aniline. If you are going to react this to do sulfonation, you need to react this with H2SO4. Then see what will happen here. You know that the nature of H2SO4, it will give you H plus and HSO4 minus. So this has a lone pair which will attack this, or this will attack on that, and it will form NH3 positive. And here comes the anionic part. So it will be like this HSO4 negative, and the bond between this and this will be ionic bond. Then you are going to heat it at a very high temperature, like 200 degrees centigrade. Then there will be formation of movement of this HSO4 minus, and here it will be NH2. Now there is a very important compound that is, or a term that is known as Zwitter ion. That is known as Zwitter ion. So what will happen? It will release H plus, and H plus will go here, and it forms NH3 positive, and here your SO3 negative is there, which is known as Zwitter ion. Migration of H plus. Is that clear?
Yes, sir.
There is a very important point that I'm going to write. I'm writing. Please do let me know when you are done with this. Basically, aniline does not undergo either Friedel-Crafts reaction, basically Friedel-Crafts reaction. That means either it will not go with all of this alkylation and acylation both. It will not go and undergo alkylation and acylation due to salt formation with aluminum chloride. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. Now see, we are going to start the new topic. Wait a minute. Are you able to see the screen? Firaz.
Yeah,
The last topic
visible.
of this chapter, thank you, is diazonium salt. What is diazonium salt? So I'm going to write the general formula of diazonium salt is basically R is your alkyl group N2 plus X minus, where R is equal to aryl group, that means benzene. And X does not only mean the halogen, but X minus may be Cl minus, Br minus, HSO4 minus, BF4 negative. It can be any group like this, etc. So these are basically diazonium salt. And we can take an example, or the most important point is that N2 plus, this group is called diazone. This group is called diazone. Okay, diazonium group. For example, we can take example like C6H5N2 plus Cl minus, and its name is basically benzene diazonium chloride. Benzene diazonium chloride. Another example we can take C6H5 N2 plus HSO4 minus, and its name is benzene diazonium. This is your benzene diazonium hydrogen sulfate. So benzene diazonium hydrogen sulfate. The most important point is that why R is not equals to alkyl group. It's because they are not stable. It's because they are not stable, and due to this benzene group attached to this N2 plus, it will be in conjugation with the resonance. That's why it will be stable. And I want you to do the write the resonating structure of this benzene diazonium. Also, it's very important to note that the bond between this and this is ionic or covalent. What do you think? Let me know when you are done. Will you be able to write the resonating structure of this benzene diazonium?
No, sir.
Okay, are you done with the after this?
Yeah.
So this N2 plus basically shows minus R effect. That means it will withdraw electron from the ring, and see how it will do. It will take electron from here, and this bond will be moved to this point. Now, since this electron gave the electron, so it will have positive charge, and this will be now double bond, and this will be double bond plus, and there will be negative charge. Now you need to only go with one arrow, and there will be positive charge, double bond, double bond. Now this will move to this. Now this will move to this, and again the same compound you will get. So this is how we write the resonating structure of the benzene diazole. Are you done with this?
Yes, sir.
Very good. Now we are going to see the preparation of the isonium salt, which is very easy. We have already done it. Methods of preparation of diazonium salts. So how we are going to prepare diazonium salt? You see here it is C6H5 NH2, and if you are going to react this with nitrous acid, the temperature should be low, like this. Then you will be getting diazonium chloride along with the byproduct MnCl. So this is how we prepare. And there is only one preparation in our syllabus. Then we will talk about chemical reaction. And this reaction we have already studied. So we just need to do revision, like Sandler's reaction will also come in this, and Gatterman reaction. Let me know.
Done, sir.
Very good. The reaction is divided into two parts. So we are going to deal with the first one. That is A, and it is basically reactions involving displacement of nitrogen. Displacement of nitrogen. So the first is basically your Sandwich reaction that we have already studied in the first chapter. That is your haloalkanes and haloarenes. This is your benzene diazonium chloride. And if you are going to react this with Cu2Cl2 slash HCl, then this N will be replaced by Cl. N2 will be replaced by Cl, and N2 will be released. If you are going to do this with Cr2, Cu2Br2 in the presence of HBr, then you will be replaced like this. And if you're going to do the reaction CuCN in the presence of KCN, the N2 will be replaced with this. Here you know aryl, that means it is benzene like this. Are you getting my point?
Yeah.
Then basically this reaction is Sandler's reaction. Sandler's reaction. Now there is another modified form which is known as Gatterman reaction, and in this you can see the reagent is changes. Only you need to react copper in the presence of HCl. Then you will be getting ArCl. copper in the presence of HBr instead of CO2Cl2 or CO2Br2, you will get this. Along with there will be N2 and CuX, along with N2 and CuX, and this reaction is basically Gatterman reaction. So this two reaction is quite important in this chapter. Let me know when you are done. Let me know when you are done with this.
Yeah.
Very good. Now see, there are other ways to replace N2 with, like, the first we can take, the second we can take replacement by iodide ion, replacement by iodide ion. So how we can replace? So Ar N2 plus Cl minus, instead of using Cu2I2, we can only mix this benzene diazonium chloride with potassium iodide, then this will be replaced with this. You have studied this reaction in the first chapter. Now the third one we can say replacement by fluoride ion. Fluoride ion. How we can replace it's also very easy. If you have Ar(N2 plus Cl minus, which is benzene diazonium chloride, you are going to use this hydrogen fluoroboric acid. So this will be first converted into this a salt, and then if you are going to heat it, then you will be directly getting this, and this. These are byproducts. And the fourth one is replacement by hydrogen. That means you will get a benzene. Replacement by hydrogen. So see, it's also very easy. If you are having Ar2 plus Cl minus, you need to use a reducing agent like H3PO2, which is a reducing agent in the presence of water. It will reduce this. That means it will oxidize itself. So basically, it will be converted into ARH. That means hydrogen connected. That means it is a benzene, and this will oxidize itself into this H3PO3 phosphorus acid along with HCl. There is another way to replace with hydrogen or convert it into benzene, that is using alcohol CH3CH2OH, which is ethanol. So this will be reduced into benzene and this will be oxidized into aldehyde along with HCl plus N2. I forgot to write N2. Very, very easy. Let me know when you are done.
Done, sir.
Very good. Now we have this, the fifth one, replacement by hydroxyl. So if you are going to directly hydrolyze this benzene diazonium fluoride, so OH will be added. That means it is your phenol. This is your phenol. It will be converted into phenol along with this N2 plus HCl, which is common in all these reactions. The next and the last one of this is replacement by NO2 group. So if you have this N2 plus Cl minus, so you need to react with this HbF4, which is fluoroboric acid. Fluoroboric acid. Then this Cl minus will be replaced by this Cl minus will be replaced by N2 plus, and here it will be B4 negative. And if you are going to react it with NaNO2 in the presence of copper and heat it, then it will be replaced with NO2 plus N2 plus NaBF. So this is how we do. Are you done with this?
You're done, sir.
Very good. Now the last reaction in which we study the B-type reactions involving retention of diazo group. Which the reaction is known as basically coupling reaction. So here you can see this is your coupling reaction. So if you are going to react this way, there will be negative, there will be positive charge. With the phenol, that means OH here and the H here, this will be reacting in the presence of base. So what will be the product? So the nitrogen will retain itself here in this form. You can see. This Cl minus will be eliminated and it will be as a byproduct, and this H plus and OH combined to form H2. So there is two reaction in this. The another is also this is same. If you are going to react this with aniline, you know what is aniline? This is your aniline in the presence of acid. Then again the rest part will be same. And this is basically its name is p-hydroxy azobenzene. Which is orange dye, vitamin. And it has a name, amino azobenzene, which is yellow dye. So here our chapter is complete. Now I'm going to give you some questions. Just let me know if you need to revise any chapter on Thursday, which chapter you want to revise. Are you done with this? Are you done with this?
Yes, sir.
Okay. I'm going to give you some question. Please do it. And after doing it, just send it back to me so that I can check it. And after solving it, you may leave. Is that clear? I'll be back from most. Firaz, are you done with this? Firaz,
No, sir.
okay, so after solving it, please send it to Learnivio's WhatsApp. After solving it, email you. Okay,
Yes.
thank you.